Good morning, everybody. After that great entertainment start with Alex and Tim, it's back to our regularly scheduled programming. And our first up speaker is our very own Dr. Phil Klotzbach, and the much awaited for Colorado State hurricane season forecast. So, Phil.
All right, good morning, everyone, and happy to report I just checked on my phone and the forecast did post. Everything's live, so woohoo, that's always a good thing. Yay, technology. Hurricane risk communications. All right, we could talk about that too. But all right, there I am. Using the fancy schmancy new CSU template this year. We're going to talk about what the heck we might be in store for 2024. I suspect the numbers that we're coming out with probably aren't going to be too shocking given, what has been discussed quite a bit. I can tell you I've done a lot more interviews in February and March than I normally do on hurricanes. We are forecasting a very, very busy hurricane season in 2024. 23 storms, of those 23, 11 becoming hurricanes. Of those 11, 5 becoming major. Category 3, 4, 5 hurricanes. It compares to the long-term average of 14 storms, 7 hurricanes, 3 major hurricanes. This is the highest April forecast that we put out. We started putting out these forecasts back in 1995 for the April forecast. This is the 41st year that we've done seasonal forecasting in general. A couple of indices I want to draw your attention to. Accumulated cyclone energy. That's kind of a geeky metric accounting for storm frequency, intensity, and duration. We actually use that as our primary forecast metric. So all of our models actually forecast ACE, and then we derive the other parameters from that level of ACE. Of course, you can have ACEs that are very similar, but very different numbers of storms. For example, we have 2004 and 2005. ACE was within about 10% of each other. 2004, it took 15 storms to generate it. 2005, it took 28. Because ACE is frequency, intensity, and duration, long-tracked hurricanes like Ivan in 2004, Irma in 2017, Dorian in 2019 generate huge levels of ACE. A new index that we started forecasting last year is ACE west of 60 degrees west, also termed as angst ACE. This is ACE in the western half of the basin, so this is when we're flying a lot of planes into the storms. That's where all the people live. In the Atlantic basin, so when you have a lot of wind energy generated in the western half of the basin, that's not great. An ACE relative to basin-wide ACE this year is somewhat higher than last year because we're expecting likely a transition over to La Nina conditions, and I'll talk more about that in a couple of minutes. But when it comes to seasonal forecasting, I had to dig out this old cartoon, try to kind of change the messaging here at the start. And so this is Dr. Bill Gray, the founder of the seasonal forecast. They're giving an award away in his memory this evening. This is not how our forecasts are done. You might think, hey, it's this is Dr. Gray looking into a crystal ball, saying, "Verily, I see 17 named storms." That's not how we do these seasonal forecasts. What we do is we use historical weather and climate information to come up with these hurricane predictions. Dr. Gray was teaching tropical meteorology in the early 1980s, and, this is long before we had Wikipedia. We had, back in the day, when we had Encyclopedia Britannica and all that great stuff. Dr. Gray knew which years were active hurricane seasons, and he knew which years were El Nino years, and he said, when we have El Nino years, we tend to get fewer hurricanes in the Atlantic Ocean. That's interesting. Now, why would something going on in the tropical Pacific impact hurricanes in the Atlantic? And so we know El Nino is warmer than normal water in the central and eastern tropical Pacific. La Nina is colder than normal water in that same region. If we look at the schematic on the left, when you have that warmer water in the eastern and central tropical Pacific, your strong thunderstorms tend to like to form over the warmest water. So in an El Nino, those thunderstorms tend to shift somewhat farther to the east. And so when you have thunderstorms, you have low-level winds converging into those thunderstorms. The air goes up in the thunderstorms. You get those really pretty cumulonimbus clouds. At upper levels, the winds diverge. So you increase your upper-level westerly winds in El Nino years relative to La Nina years. However, your low-level winds in the tropical Atlantic blow out of the east. These are the trade winds. They pretty much always blow out of the east. At upper levels, they tend to blow out of the west. So in an El Nino, you have a lot stronger westerly winds, much more vertical wind shear. Too much vertical wind shear is detrimental for hurricanes, tends to help tilt the hurricane circulation, disrupt it, and you get fewer hurricanes and weaker storms in general. So El Nino tends to knock down your storms. La Nina tends to really increase your storms. But it's important to take into account a lot more than just the El Nino La Nina phenomenon. As we saw last year, we had a busy hurricane season well below normal shear with a strong El Nino because the Atlantic was so dang hot. And also kind of, I think, somewhat the structural, the sea surface temperature anomaly pattern that we had across the tropical Pacific last year, I think also was another factor. So, how good are these forecasts? And so one thing I do emphasize is, unfortunately, in general, the April forecast gets the most media attention. I wish it were the later forecast because this is kind of like putting your most focus on a 10-day weather forecast as opposed to the forecast for today. The skill of the forecast does improve as we get closer to the events we're trying to predict. So we can see at the left is April, then we go to June, you go to August, the columns get higher. But one thing I also want to draw your attention to is the red column is higher than the blue column, meaning we're getting better, which is good. And there's a couple of reasons for that. One, the historical data that we base our models off of is better than it used to be. And that's kind of funny to think, how could history be better? But we now have better models that can basically take the historical observations that we did have and give us a more accurate representation of what the globe looked like. Another big factor is we have climate models now that can forecast 3-6 months out. Now, we're not looking for, say, a forecast for a specific day, but a 1, 2, or 3 month average. So I'll talk more about how we use them later, but that's one of the reasons why the forecasts last year, especially the June, July, and August forecasts, were quite successful, is because in general, the proverbial wisdom was if you have a strong El Nino, it dominates over everything else. But the climate models last year said we're going to have a strong El Nino, the Atlantic is going to be record warm, and we're going to see low shear in the Atlantic, and that actually played out quite well. So that kind of gave us increased confidence, and I think we would have had, say, 20 to 30 years ago where we didn't have skillful climate models. So here's what we're currently looking at. So there's still a lot of red globally, so the globe is quite warm, but really one of the things that we even started thinking about last year was, okay, the Atlantic's record warm, assuming the strong El Nino dissipates, which they normally do, how is that going to play out in 2024 if we have the continued warm Atlantic, but without the El Nino putting at least somewhat the brakes on, especially in the western part of the basin? We didn't see much storm activity in the Caribbean last year. So right now we still have that El Nino, but it really is truly skin deep. There's not much warm water beneath the ocean surface, and that's more a harbinger of what we're likely to see in the next few couple of months, is a quick transition, I think, to neutral and probably La Nina conditions. We can see the Atlantic is also still extremely warm. The anomalies have come down just slightly, but we're still well above the long-term average and still at record warm levels for the latter part of March across most of the tropical Atlantic. So we're going to talk about two regions in the next few minutes. The first, that blue rectangle, denotes the NINO 3.4 region. That's the region that NOAA uses to monitor the state of El Nino and La Nina. That's what happens when you let scientists name stuff. We come up with exciting names like the NINO 3.4 region. In the Atlantic, we have the Atlantic's main development region, which is so named because that's where your hurricanes tend to develop and intensify in the Atlantic. And so if we see that, obviously, again, running at very, very warm levels right now. So here's what we have, again, in the tropical Pacific. We still have that El Nino. Right now, it's borderline weak to moderate in that box. It's about 1 degree Celsius-ish warmer than normal. But if you look at the subsurface, the water's beneath the ocean surface. So this is going down 300 meters or about 1,000 feet. The waters are quite cold. And so typically what goes on in the subsurface is a good predictor for what you're going to see at the ocean surface. And I'm sure we all love our Hofmuller plots. So on the top of this plot is basically now, and on the bottom of the plot is the middle of May. And this is averaged over 5 degrees south to 5 degrees north, so generally right along the equator. And so in this plot, blues indicate easterly winds out of the east. Reds indicate winds out of the west. And if we look across the tropical Pacific, we see a lot of blue, indicating that we're getting stronger trade winds blowing across the tropical Pacific. That tends to basically enhance upwelling, bringing up colder water to the surface. So I suspect we're going to see those warm waters in the tropical Pacific likely dissipate here and potentially have a quick transition over to La Nina. which matches up quite well with what NOAA, National Oceanic and Atmospheric Administration, is saying. Greater than 80% chance of La Nina for August through October. That's quite an aggressive forecast. I think physically that makes sense. But you can see, if we're looking for El Nino, that's about 1%. So, the odds of El Nino this summer and fall are very, very low. There's a whole lot of different models, so if you want to get into the El Nino modeling game, you're kind of late. There's a whole pile of different models forecasting ENSO. And so we have dynamical models, which are full physics models of the atmosphere ocean. We have statistical models, which are based on historical data. If you love acronyms, there's a whole pile of acronyms. I can probably tell you about 2/3 of them, but there's some I have no idea what those stand for. But most of them are calling for La Nina. Some are calling for neutral, but you see there's nothing above the El Nino threshold for August through October. If we go closer to home, this is the North American Multi-Model Ensemble. So these are 7 models from the United States and Canada. And all of them by September, which is what's denoted by the black arrow, are calling for La Nina conditions. And again, these are all for March. A lot of these plots will be updated here in the next couple of days. You can check on these various websites and get updated forecasts of ENSO coming up shortly. So why do we care? So I wanted to go back and kind of quantify, why do we care about El Nino and La Nina? We say it matters, but how much does it matter? And so this is basically going back to 1900 and looking at the number of storms, hurricanes, and major hurricanes by ENSO phase. So we have La Nina, we have neutral, and we have El Nino. And here we're going back to 1900. So especially the named storms, those numbers before the satellite era in the mid-60s are likely somewhat underestimated, but the ratios are probably held up reasonably well. And so here we're taking the 30 coldest years, calling them La Nina, the 30 warmest years, and these are all for August through October, calling El Nino, and the rest are calling neutral. So you can see, a little bit like 1.5 to 1-ish, 1 3/4 to 1 for named storms. By the time we get to major hurricanes, the ratio is more than 2 to 1. Makes sense because you can get marginal storms in not particularly conducive environments, but to get a major hurricane, you got to have a pretty decent area of conducive conditions. So you see greater than 2 to 1 ratio for La Nina and El Nino. Then I said, well, I got to put on my old GIS hat from back in the day, make some plots. And so here we're looking at major hurricane tracks. In La Nina versus El Nino, it's the same number of years for both. And you can see, obviously, which would you rather be in, right? I mean, obviously, the El Nino has a lot fewer, and you see a lot fewer tracks in the Caribbean. El Nino really increases your shear down there. And you can see, there's still some landfalls especially from like Texas to Alabama, maybe up into the Panhandle. But if you look, more Florida to Maine, you see a whole lot more tracks in La Nina than in El Nino. So if we look at the differences for Texas to Alabama, and we look at ENSO phase, we do see there is a relationship, but it's fairly weak, and some of that is due to the fact that, Gulf or Texas to Alabama hurricanes can form, off the coast of Africa, come all the way across. They sometimes come out of the Caribbean, but you can also homegrown storms, and those homegrown storms don't have much of a relationship with ENSO because often they're more frontal in nature, at least the way they start forming. But if we look at Florida to Maine hurricanes, we do see more significant ratios, especially for major hurricanes, about 2.5 to 1. And that's because a lot of those storms are the ones that come off of Africa, come all the way across, and those conditions tend to be more conducive in La Nina years. La Nina years also, very broadly speaking, do have a little bit stronger subtropical ridging, so it tends to push the storms a little bit farther to the west. Unfortunately, a lot of those relationships are stronger in the winter than they are in the summer. Summer signals in the mid-latitudes tend to be fairly weak. So what I thought was interesting was, let's actually look at damage. And so here we're looking at is normalized damage. So obviously we know these storms in the past, if they were to make landfall today, would cost a lot more money due to changes in inflation, which is not an insignificant thing, as well as population and wealth. And so, for example, we talk about this 1926 Great Miami Hurricane, caused about $80 million in damage in 1926. That hurricane, if you do a normalization, is about $200 billion today. So if we look at these $10 billion storms and we look at the odds by ENSO phase, certainly, obviously, the odds get much higher, especially for Florida and the East Coast in La Nina. You might be wondering, what is that 3%? What year was that? So again, we have 30 years, so 3% is 1 year, but that year was 2004. So again, it's important to realize that you want to look at more than just one index at a time when you're talking about hurricane seasons. The Atlantic's still hot. Now, if I had shown you this plot even like 3 weeks ago, looking at a 14-day average, it would have even been darker red, so that we have backed off a little bit, but it's still extremely warm in the Atlantic. Pretty much the entire Atlantic is very warm right now. And unfortunately, if we look at the correlation map that we normally see, so this is a correlation map of April sea surface temperatures with accumulated cyclone energy. And if I this is basically the optimal pattern for a busy hurricane season. If we step back and look at that, and then we look at that, it's not a correlation of 1, but that's pretty close. So that's, again, one of the big reasons why we're forecasting a well above normal hurricane season. If you look at the current sea surface temperatures in the tropical Atlantic, and you say, okay, we're going to warm at the slowest rate that we've warmed between now and the peak of the season, you're still talking water temperatures that are, say, like top 5 warm. So unfortunately, I think this is a little bit of somewhat of the die is cast for 2024. Now, certainly you can get atmospheric patterns that can cause this to anomalously cool, but just given how warm it is, it's going to be hard to shake all of that warmth between now and the peak of the season. These anomalies are highly elevated. 1 to 1.5 degrees Celsius warmer than normal in the deep tropics. That's a big deal. That's a lot of warmth. And so what I wanted to do next is we'll talk a little bit about some of these climate model forecasts. So this is the forecast from the North American Multi-Model Ensemble, so those 7 models from the US and Canada. And again, this plot will be updated on the 8th of April, but I suspect it'll be fairly similar. So it's calling for a robust La Nina and a very warm Atlantic. And so what I wanted to highlight next is relationships that we see with basically what we see when we have a very warm Atlantic. So we can see the model projections are for a very warm North Atlantic relative to the southern tropical Atlantic. And that is typical of what's known as the Atlantic meridional mode. Some of you may have heard of this, but basically it is when the northern tropical Atlantic is extremely warm relative to the southern tropical Atlantic. When that occurs, you tend to get lower pressure in the northern tropical Atlantic. You get more cross-equatorial flow. With Coriolis, you tend to get winds out of the west at low levels, which helps to spin up storms in the eastern and central tropical Atlantic. It tends to also favor more, basically it helps bring moisture onto the African continent, helping to revitalize the African monsoon. You get enhanced precipitation across the main development region, again, likely causing more conducive conditions for hurricanes in 2024. And so we can do the same analysis we did with ENSO, but with the Atlantic meridional mode. And if we look at these relationships, we again see stronger relationships for major hurricanes than we do for the number of storms. This AMM index goes back to 1948. So here we're looking at the 19 years where that index was the most positive in August through October. Those are our positive years. The years that are most negative, the 19, are negative, and everything else was neutral. And again, if we look at the plots, you see one of the things that the AMM does is it really impacts storms in the eastern and central part of the basin. You get a lot more formations there, and you can see, right? If you look at the negative AMM and you look east of the islands, there's 0, no major hurricane tracks out there. And so when you have the AMM positive, you start to get a lot more tracks in the central and eastern Atlantic. And again, you see some landfalls for Texas to Alabama, negative AMM, but again, really highlighting more storm formations potentially, and potentially some more storms up towards the east coast. If we look for Texas to Alabama, again, you do see an increase in the relationship with when the AMM is positive, but a little bit stronger for the for Florida up to Maine. We could do the similar analysis with the $10 billion storms, and we do see more when it's positive than when it's negative. But again, the relationship is a lot stronger for Florida up to Maine. But then what you can say is, okay, well, at this point, the odds are pretty good we're going to see a positive AMM. I'd say that odds of that are extremely high. Odds of La Nina also pretty solid. So if we look at the 11 years where we had a positive AMM and La Nina, so combining basically the Atlantic and the Pacific, compare with the negative AMM and El Nino, you start to get really pronounced relationships, about 4-to-1 for major hurricanes as well as major hurricane days. You just see a lot more storm activity in general. So, we can't say for sure that's what's going to happen, but I would say the odds certainly favor the top plot. Obviously, the odds of the bottom plot, if that happens, I'd need to go back to school and try to figure out some other stuff to do, because that would be extremely surprising. All right, so again, if we quantify this again, we're talking about a 4-to-1 difference, especially for major hurricanes. Again, highlighting how the stronger the storm, the stronger the relationship, because again, you need a much larger area of conducive conditions for the stronger storms. So what I wanted to do next was talk about some of the model projections. So the European Center model, these will actually be updated tomorrow, but their forecast in March was for a pretty cold tropical Pacific. This is kind of borderline La Nina to cool neutral. I think honestly, even if we don't go all the way to La Nina, assuming the Atlantic remains extremely warm, it doesn't necessarily really matter in terms of activity. We likely would still have a very busy season. The Atlantic also very warm. And so the European Center model, in addition to basically forecasting the large scale, they'll actually track storms. And so they can count the number of hurricanes. And so this kind of distribution of storms in the northern hemisphere is very classic La Nina, where the western North Pacific is down, the eastern North Pacific is down a little bit, and the Atlantic is highly elevated. So right now the forecast goes out through September. And so from April through September, the model is forecasting a highly elevated amount of storms. So the forecast is for 8.7, and you might be wondering, how on earth do you get 8.7 hurricanes? I've never seen 7/10 of a hurricane. I mean, you could argue some of these sheared things are, half a hurricane. But the way that happens is you have an ensemble. You have 51 members, and so, each member would have a round number, so, 9 hurricanes. But if you have 9 hurricanes and you have 8 hurricanes and you average it, you have 8.5. So that's how we get 8.7. And that's only through September. On average, October has 2. So you could say with that, probably about 11 hurricanes for the season. That's, again, kind of basically what we're forecasting. So in line with what is being forecast by the European Center. And again, this forecast will be updated tomorrow. I know everyone wants to know, where are the storms going to go, right? That's the million-dollar question. And so, last year, not in March, but more like April and especially in May, the European Center, UK Met 2, we're highlighting enhanced precipitation. And I like to look at enhanced precipitation, especially in the deep tropics. This isn't a bad harbinger for tropical cyclones. And if we look in July through September, which again is as far as the model goes, you do see enhanced precipitation, but it's more in the western Atlantic, which is again a classic La Nina signal. And so, obviously this is not perfect. If you look at the skill mask, there's not a ton of skill forecasting this far out, but highlighting kind of what you more would expect in La Nina really enhancing your storm formations and enhancing activity in the Caribbean. Because again, as we saw last year, it was a busy season, but not much in the Caribbean. The Caribbean had a lot of sinking air last year. If we switch to La Nina, the air should be going up more in the Caribbean, likely making that area more conducive. Obviously, Caribbean storms, what we really don't want, because obviously they either impact Caribbean, Central America, sometimes also get lifted up by troughs and start impacting to the U.S. So how do we come up with these forecasts? Well, we use a variety of different techniques. And so this is kind of the throwback technique to what Dr. Gray was using in the early 1980s, and that's a statistical model. And so the statistical model says, okay, we got to do the forecast April 1st. We only have data through March. So let's look through March and see what conditions during basically the winter, early spring correlate with hurricane activity, several months later. And so we use 3 predictors, 2 sea surface temperature predictors, one in the Atlantic, one in the Pacific. So the Atlantic predictor is getting basically your overall basin warmth. The Pacific predictor, when the water's in the Coral Sea all the way up to north of, basically when those are warm, that tends to help support a transition over to La Nina. And we also look at upper level winds over the Atlantic. There's actually somewhat of persistence there. When those winds are anomalously out of the west, that tends to mean more reduced levels of upper level or anticyclonic wave breaking, which can cause increases in shear and have been a bane of our existence. A lot of our forecast busts have been due to enhanced tropical upper tropospheric trough and shear associated with that we didn't expect. And so this model is certainly not perfect. You're never going to get correlations of 1. And especially in April. But in general, the model does a reasonably good job. There are some forecast busts. Again, it's April. The hurricane season starts June 1st. Doesn't really ramp up until August. Dr. Gray used to ring a physical bell every year on August the 20th, signaling the active part of the hurricane season. Certainly last year, we went through August 15th or so, and it was very, very quiet. You looked August 19th, the Tropical Weather Outlook had 5 areas on it. All 5 of them formed. We got extremely busy, and that's why we issue these updated forecasts, because even though season starts June 1st, doesn't really ramp up until August. And again, so we can see the models has reasonably good levels of skill going back to the late 1970s, basically the kind of the global coverage of satellites. So this model is extremely active. You're talking ACE basically at record levels. And so the final forecast is actually below all of our model guidance from all of our numerical models that we used. But still, certainly a very, very active season. Overall, at this early lead time, I think we need to be a little bit careful in terms of going too much higher than what the forecast has. We also use statistical dynamical models, and these are models that Dr. Gray couldn't have had in the early 80s because we didn't have climate models forecasting 3-6 months out. But now we can. And one of the nice things with these models is that they have basically a hindcast period, so they can say, okay, how good are these models based on past data? And since they're based on dynamical equations that govern the atmosphere and ocean, in that case, past performance should be, at least somewhat, a good predictor of future results. So we can look and see, how good are the models at forecasting, sea surface temperatures. So here we're looking at forecasts through the month of August. So we're looking at August forecasts of sea surface temperatures in the tropical Pacific. So basically assessing the state of ENSO. Also looking at temperatures in the tropical and subtropical Atlantic. So if you're looking for a busy season, you want warm in the Atlantic, cold in the Pacific. Opposite obviously generally leads to quieter seasons. So we do this for a few different models. This is the, we're going to use the European Center model as an example. So here's the plot I showed you before, but with the Pacific box and the Atlantic box drawn on to give you an idea of kind of what you would expect for values there. So you would say, okay, very warm Atlantic, cold Pacific, likely leading to quite a high hurricane season. And the model shows reasonably good levels of skill. You get about 35 or about 40% of the variability, which isn't bad for early April. Again, there's still a lot that can change. As you would expect, if I were to show you the predictions from June or August, the skill improves because, again, we're closer to what we're trying to predict. The European Center model, this statistical dynamical model, ACE, is about 230, which, again, is extremely elevated. If you were to actually take the ACE that the model was actually forecasting, it would actually come out with a level approximately similar to that as well. We have a whole pile of other models that we use. We use one, the UK Met Office model, the Japanese Meteorological Administration model, and a research model out of Italy. All three of these also calling for an extremely busy hurricane season. So if you go into our forecast on our website, there's a whole lot of discussion about why we came up with the numbers that we did. It's not just the forecast numbers. There's a lot of work that goes into this and a great team of people working on this. And so we also use analogs. And so, analogs are tricky. Obviously, there's like snowflakes, no 2 years are exactly alike. And so this year we actually went way, way back in the historical record books to try to kind of get some better analogs. The question is, what do you want to use to pick your analogs? You can go back and you can try to, look for years with a really warm Atlantic, but you want years that were transitioning over from El Nino to La Nina, and trying to kind of find all of that there's not a ton that had all of that, especially in Atlantic as warm as it is now. So you kind of have to sacrifice something for each of these years, because obviously from a warm Atlantic perspective, the year I'd want is last year, but obviously that was a strong El Nino. So we went back and we found 5 years that I thought were reasonably good analogs. So the first one is all the way back in 1878. In 1877 was certainly a very strong El Nino. There's a lot of evidence, in addition to kind of marginal water temperature records back then, that was a strong El Nino. So 1878, and it was a pretty busy hurricane season based on the data that we have back then. Obviously, like we missed some storms in 1878 without aircraft and obviously no satellites. Another year we selected was 1926, obviously an extremely busy hurricane season that year. And then we selected 3 years, 98, which was coming out of a very strong El Nino, 2010, which was a moderate El Nino, and then 2020, which didn't have El Nino, but the Atlantic was extremely warm that year, and was kind of a marginal warm neutral-ish event in 2019. So again, not a lot of perfect analogs, but these are the 5 years at this point that we thought matched up the best, and this is the composite of those 5 analog years. So a cold tropical Pacific and a relatively warm Atlantic. And so here's the activity average in those 5 years. Certainly named storms in 1878 and 1926. Those numbers are way too low. I don't know what they are, but certainly we had more than 12 named storms in 1878 and 11 named storms in 1926. If you have an ACE at 230, you've got to have more than 11 storms, I would guess. But overall, you can see a lot of storm activity in those years. Overall, if you were to kind of take in, especially those first 2 years, and add a few storms, likely some ACE, the numbers would match up pretty well with our final forecast. And again, there aren't any perfect years. Certainly if others were to do analogs, I'm sure guessing they would come up with some other years, but these are the 5 years that we thought worked the best given the current large scale. Obviously, these forecasts aren't perfect, so what we try to do is we calculate the uncertainty associated with these forecasts. And obviously, this is April, so the uncertainty is fairly large. So we can calculate probabilities of exceedance. So basically, take the kind of observed climatology of ACE, in this case, and then we can basically fit that to a statistical model, and then basically estimate the uncertainty associated with these forecasts. Because obviously we know these forecasts aren't perfect. So using the historical errors of our statistical model, we can calculate a 70% confidence interval. So, we have all the way up to like the most active season on record, potentially, but also all the way down to a year pretty similar to what we saw last year in terms of ACE. And we can do a similar analysis for all of our different parameters. And so these are our uncertainty ranges. And if you look at NOAA's forecasts, they're pretty similar in terms of their spreads. Usually it's about 2 to 3 hurricanes, maybe two major hurricanes. And again, these uncertainty ranges, if you say look at our June forecast, those uncertainty ranges will be a little bit smaller because we're more confident about the predictions as we get closer to the events that we're trying to predict. But just at this long lead time, there's just a lot of uncertainty. So when people say, how confident are you historically, it's about plus or minus 3 for hurricanes. This year, I'd say we're a little bit more confident, certainly, than we were last year at this time, just given last year was kind of like these two big giant factors going at each other, whereas this year it's looking more like they're all going to be kind of pulling the same direction. As I mentioned before, we do forecast ACE west of 60. The reason we do that is because, again, that's where people live, and so when we do our forecast, we want to kind of highlight more where people are likely to be impacted. And we can't say, months in advance, a storm's going to make landfall in a specific spot, obviously. But we can try to highlight, okay, maybe the western half of the basin is going to be busier. So last year, we were pretty confident, even in April, that we're going to see a pretty healthy El Nino, and that confidence just grew with time. And obviously, it was a strong El Nino. And so we said, okay, as we got closer, we said, okay, we're likely to have a busy season, but probably not a ton of, basically a little bit less ACE west of 60, because you tend to have, the Caribbean tends to be less conducive, and also it tends to favor broadly a little bit more recurvature east of 60 west. And so again, these differences aren't huge. It's about 50% in El Nino, 60% in La Nina, but because we are pretty confident we're going to see La Nina, the percentage of ACE west of 60 is higher, due to two factors. One, the Caribbean's likely to be a fair amount more conducive than last year, and also potentially a little bit more straight moving tracks, but that relationship is a bit messier. So we do probabilities of landfall, and the way that we do these are we calculate the historical odds based on historical data, and then we adjust them based on now ACE west of 60, because obviously all the land masses we're forecasting for, except for a couple of the far eastern Leeward Islands and Cabo Verde, are west of 60 degrees west. So if we look at the probabilities this year, they are elevated, not a surprise, because we're forecasting a above normal hurricane season. And what we did a couple of years ago with help from colleagues is we calculated for every county along the coastline and parishes for Louisiana, the odds of storms making landfall, but not landfall. We wanted to look at storms within 50 miles of each county, as well as each state, each island in the Caribbean, each province in Canada that's hurricane prone, and as well as the coastal states of Mexico on the East Coast. Because we want to try to get an idea of, you don't have to have a storm making landfall in your county or your state to have significant impacts. If something's within 50 miles, you're not having a good day. So we wanted to expand it a little bit and helps kind of smooth out the statistics as well. So here we're looking at Plymouth County, because that's where I grew up. And there's not a ton of hurricanes, thankfully, to hit Plymouth County. But if you look back historically, there's been 10 from 1880 to 2020. And we did this analysis using this this really awesome coast.noaa.gov hurricanes website, which has all this historical hurricane track data, because that way it's easily replicable if someone else wants to go in and do it. They should get the same answers as we did. Except when the Hurricane Center reanalyzes years, sometimes that can change things a tiny bit. But overall, we calculate the historical odds of storms within 50 miles. And so on our website, we have it for every county. And like I mentioned, all these other regions. Here's an example of several states. We do have it for every state, but I didn't want to have a font of 8 point on this plot. So we're in Texas, right? So let's look. The probability of a hurricane in Texas, or within 50 miles of Texas in any year, is about 35%, 36%. This year, it's elevated at 54%. And again, all of this is on our website. So if you want to kind of dive into more detail on all these interesting, at least what I think are interesting statistics. So we will update the forecast. We'll update it again on June the 11th. We'll update it again on the 9th of July, and a final update on the 6th of August. And again, people will say, oh, the 6th of August, that's 2 months into the season, that's cheating. Well, they'll say it's like issuing a forecast for the Super Bowl at halftime. It's more like issuing a forecast for the Super Bowl after the opening drive of the game. There's a lot that can happen between early August. Usually only about 5% of your major hurricanes occur by the 6th of August in an average hurricane season. If you can't get enough of seasonal hurricane forecasts, I invite you to check out seasonalhurricanepredictions.org. We've got about 30 different groups that have submitted or that submit seasonal forecasts each year. The number changes a little bit each year. Sometimes groups drop off. We get new groups. So all of these groups, we have private sector weather companies, government agencies, as well as universities. I will note that there are more hurricane forecasts from universities in landlocked states than in states that border an ocean, so take that as you will. They used to ask Dr. Gray why forecast hurricanes from Colorado, and he said it's because a storm surge can't get you at 5,000 feet. So we have all these forecasts, and to give you an idea of what this website looks like, here's a visualization from last year. So on the y-axis, you have an orange dot, which is the average of all the different forecasts. The red dot is the observed value. So last year we had 7 hurricanes. And so these forecasts are color-coded. So purples are private sector weather companies, greens are universities, and blues are government agencies. So we have a whole pile of different forecasts. And one of the reasons why we wanted to get this website started, and we worked very closely with the Barcelona Supercomputing Center, who hosts the website and does great maintenance on it, is that we wanted to kind of highlight the uncertainty associated with the forecast. And so some years, the spread of the forecast isn't very much. Like this year, I'll show in a second, the forecasts are pretty much all calling for a well above normal season. But last year there was a fair amount of spread, and that's because there was a lot of uncertainty as, what's going to win with this clash of the titans between the strong El Nino and the extremely warm Atlantic. So that's really one of the reasons why we wanted to get this website started. So we started in 2016. We're gathering statistics each year. We'll probably start to do some verifications once you get maybe 2 more years. When you get about 10 years of statistics, you can kind of see, which if there are particular groups that are, doing much better than others. I mean, all in all, probably when you look at it, the statistics are going to be kind of muddled because there tends to be a lot of agreement in some years, but certainly other years, like last year, there can be a little more disagreement. So this is the forecast for 2024. This plot hopefully now includes my forecast as well, or our forecast at CSU. I just put in the numbers right before coming down. It usually updates every hour, so we'll see. If you go to the website, maybe it's there. I don't know for sure. But the forecasts so far are elevated. The red dot is 0 because we haven't had any haven't had any hurricanes yet. The average of these forecasts is 10. Obviously, putting the CSU forecast, it'll bump up the numbers a little bit, but still, still looking at a very elevated season. We'll see what transpires. There should be a few other groups submitting seasonal forecasts here in the next couple of weeks. There's also a couple of forecasts I know that have been submitted or that have been issued that we're working on getting right now. There's been some some login issues that always can occasionally plague things when you're putting in seasonal forecasts. But certainly whenever we do forecasts, I know we got a lot of forecasters here in the room. I know I've probably shown this slide probably much every year, and I know Dr. Gray before me. Arago's admonition, he was the head of the Paris Observatory in the middle of the 19th century, and he said, never, no matter what may be the progress of science, will honest scientific men or women who have regard for their reputations venture to predict the weather. So with that, I'd like to thank you very much, and I will try to answer any questions. So thank you. Yeah, I mean, so it's hard to necessarily know if we're going to see more Caribbean formation or just that we're going to see more storms tracking into the Caribbean. But I think the odds certainly favor that. And obviously that increases the odds of impacts certainly to that region as potentially well. If you get more storms in the western part of the basin, that obviously can also impact the Gulf, Florida, potentially up the East Coast. Again, the steering stuff we really don't know this far in advance. And even if we had a perfect forecast of a subtropical high for a month, it's what happens the day the storm's there. And there's not as much persistence. Like, tropical weather, in a way, is nice because if you have these conditions in July, you're probably going to have similar anomalous conditions in August, which is why the August forecast has pretty good skill because July is a nice month because normally we don't get a lot of storms, but you can kind of see, is stuff trending poorly, or, depending on your point of view, is stuff trending poorly for hurricanes or well for hurricanes? It gives you a lot of information. But the subtropical high is a pernicious beast and tends to move a lot day to day, and it's exactly how it tracks along it. But, you look at the, if you Google search for or search the Hurricane Center forecast discussions and look at like the western periphery of the Bermuda high or the subtropical high, it's in there a lot because that's really critical for exactly when these storms recurve. And also critical is also exactly where these storms form. Storms form right off of Africa, which there's that potential this year too. Generally, stronger storms have, just due to the beta effect, tend to track a little more north of due west, and those storms are more likely to recurve. Obviously, you have your Irmas, but if storms form generally right off Africa, as long as it's not super low latitude, that tends to be kind of what you want because it tends to be more recurvers, whereas obviously kind of the worst areas of storms form between like 40 and 50 west at 10 north. I mean, the odds of that not causing somebody a bad day are pretty low. So that, again, is stuff we really can't really say. But I think one of the things that, again, we're trying to kind of help is at least try to highlight, okay, when you have La Nina, it does tend to increase your odds of at least, more impacts, at least in the western half of the basin. Whether that's U.S., Caribbean, Central America is harder to say. Obviously, the smaller the region you're forecasting for, the lower levels of skill overall you're going to have. So ACE west of 60 correlates better with North American landfall. So saying anywhere, whether U.S., Caribbean, Central America, I just count each landfall as one storm or one landfall per hurricane. You definitely see an improved relationship than just saying the basin as a whole. Sure. Yeah. Hal.
So one of your slides showed the optimal springtime Atlantic SSTs for an active season, and what I thought was interesting is the warmest pool of water wasn't really in the MDR. It was off the coast of Morocco, Spain, and Portugal. Will that usually then drift south, or why is that?
Yeah, there's a couple of factors. So there is a little bit of just around that subtropical gyre, it tends to come in a little bit, but also when you have the warm water in the subtropical Atlantic, that is really critical, and the correlation actually even gets stronger as you get into May and June, and that's due to the fact that when you have warm waters, you tend to have lower pressure, and when you have a weaker East Atlantic, so a weaker Azores high, so anomalous low pressure, that tends to force weaker winds blowing across the tropical Atlantic, since your subtropical to tropical pressure gradient is reduced. Weaker trade winds mean less evaporation, less upwelling, and so that's what we saw. What came on crazily strong last year was the subtropical ridge basically just died. So we had very low pressures in the subtropics, so we had very weak winds blow across the Atlantic for several months. So we went from February of last year, where the water temperatures were kind of near average, to record warm by like the end of May. And so, when I talk about, hurricanes and climate change, and I say, okay, climate change kind of loads the dice towards warm events, but when you go from near average to record warm in a few months, that's not climate change, that's weather. And that's what we certainly saw last year. So not to say you couldn't have the exact opposite happen, but as Yogi Berra would say, Dr. Gray was a big fan of Yogi, would say it's getting late early. We're going to have to get some changes in a hurry if we're going to, take those dark reds and make them, basically go to blue. It's going to have to happen really quickly. Sure.
Is that your thinking that the primary reason we have the anomalous warm was the breakdown of the Azores high?
Yeah, and it was quite dramatic, and and so we actually have a paper right now that's in review in BAMS on the 2023 season, and we really kind of tried to highlight that as one of the primary factors that really kind of preconditioned it. And it's interesting. You can go back. I didn't put it in the paper. We didn't put it in the paper because you might have gotten a little more pushback from reviewers, but you can actually tie it back to a sudden stratospheric warming event in late February that kind of broke down kind of the ridge. And not all sudden stratospheric warmings are equal. Some have big tropospheric interactions, some have very little. Why it persisted so long, generally, once you get the waters warm, it'll tend to load the dice towards low pressure, but yeah, it's a feedback, but you have to have it be persistent long enough to get the waters that hot, and that, it's a little more like you have to really start going in and try to figure out what was going on with the Rossby wave train in March and April. But it's generally been, subtropical highs have generally still been weaker. There's been some times where it's gotten stronger, and you can still hit the mid latitudes with the hammer this time of year. But again, it's got to happen pretty quickly.
Do you recall whether the climate model forecast of SST captured that?
Not early. No. So yeah. And so actually, we also highlighted that in our paper, that the models last year did a really good job at ENSO. Even in March, they really highlighted a pretty robust ENSO event. but they didn't highlight the Atlantic being as warm, which is why when it came last year, I said, it's going to be, probably slightly below normal season when in April. By the time we got to June, July, and August, we increased the numbers because we said, okay, stuff is looking more like we're going to have an extremely warm Atlantic. But in April, that wasn't anticipated, which again is why I try to always emphasize, stay tuned for further updates because still a lot can change. We could see something crazy happen the next few weeks and suddenly the Atlantic is not nearly as warm as it is now, but that would definitely be something to write home about if that were to happen in the next few weeks.
Excellent work, that's fascinating. Another question.
Thanks. Yeah, Barry.
What about potential MJO phases? Thoughts to where that would go?
Yeah, and so, MJO is something, we can't really see what's going to happen during the season. And sometimes the MJO is strong, sometimes it's weak during the hurricane season. So if you can superposition MJO enhancing convection over Africa at the same time as you have a La Nina and an extremely warm Atlantic, that would lead to like a crazy, basically a crazy bunch of storms in a row. But if you can get a really strong MJO that's basically kind of counteracting that, you could potentially squelch somewhat the season. I think that's a bit of why these seasonal forecasts, you only get like 60% of the variability, even if you have perfect knowledge of the large scale during August through October, because the Atlantic season is so peaked. If you can tweak stuff one way or the other, September, like last week of August through mid-September, that's the time where the season has to go if it's going to go. And so if you can counteract that, you can potentially do stuff. But with the MJO, it has been quite robust. It's been really, if you actually were to take like these Hobmaulers and look at your velocity potentials, you'd say this is like classic what you should see with an MJO, nice propagation around the globe. It's been going pretty quickly. There are some indications it might be weakening, but it's hard to really say, but that's certainly something. So we do the seasonal forecast, and we also do the sub-seasonal forecast, where we try to predict out about 2 weeks. I try to highlight what might be coming in the next 2 weeks, and then we can do more than say, okay, these broad areas. Then you can start kind of looking at some of the forecast model ensembles and saying, okay, maybe there's a signal of something, week 2 in a specific area. And so last year we issued a forecast, I think it was like August 18th, and we said, looks very busy coming up, but probably of most interest, because the stuff off Africa is probably going to recurve, is potentially something coming out of the Western Caribbean, Southern Gulf in about 10, 12 days. And that was Idalia. At that point, we couldn't say, where it's going to go, but hey, this is something that's concerning, because when stuff's coming out of that area, that's not good. So that's something else that we do, is try to kind of have that like 2 week time frame. And then obviously once you get to within 1 week, that's, the Hurricane Center obviously puts out their tropical weather outlooks that go out a week. And also Climate Prediction Center goes out, they have week 2 and 3 TC forecasts as well, where they're looking at, kind of similar stuff to we are, kind of trying to highlight where stuff might go.
Other questions?
I hope I'm not showing my meteorological ignorance here, but could the Tonga eruption of 2022 be having any impact on that?
I've seen some chatter. I haven't seen anything published on it in terms of its impacts on the Atlantic. I know, because they erupted in 2022, some people are trying to blame August of 2022 where we had no storms on it, but I didn't really see a whole lot. I think its impacts probably would have been a little too high up in the atmosphere to cause too much impacts in terms of the hurricanes in the Atlantic. And so that kind of goes back a little bit to, I was talking with Craig Setzer last night about this, like the quasi-biennial oscillation. CSU, we used to use that, and why don't we use it anymore? And there was always kind of a debate, was it, when you get up into the stratosphere, how much of the hurricane actually extends up into the stratosphere and how much that matters above about like 100 millibars? Probably not a ton. So yeah, it's definitely more troposphere related. So, our seasonal forecasts, we're always looking for new predictors, and we sometimes will have to tweak them, because if you look historically at predictors, sometimes they'll work stronger and sometimes work weaker, and that's because Dr. Gray used to always say the global atmosphere-ocean system functions as a single unit, and certainly it does. So if you change things in one spot, it can then change kind of how all these teleconnections that we use then go back to impacting hurricanes. Yeah?
Sorry if I'm asking you to repeat yourself, but you made a comment about homegrown storms, and I assume that was Gulf and Caribbean formations, and versus the Atlantic when it connected to El Nino and La Nina, and I didn't quite track what you said there exactly, if there is a connection or not, and what those expectations might be.
Yeah, so when I was talking about homegrown, I was meaning basically in the Gulf of Mexico. And so when you get storm formations in the Gulf, sometimes those can be seeds that come from Africa, but you can also get like these basically frontal kinds of systems like we see early, especially like early in the season. And those, frontal kind of systems don't have much of a relationship with much of anything. So that, I think, reduces a bit your predictability for the Gulf in terms of like a seasonal forecast because, again, you can get storms out of the Caribbean, storms coming off Africa that go all the way into the Gulf, but those homegrown storms, they're predictable on weekly timescales, but not really on seasonal timescales. They just don't relate as well because of their nature, basically the nature of how they form. Yeah, exactly. Alicia is a great example. If you go back and you look at the busy years versus the quiet years, you get a whole lot more landfalls in the busy years, but you can have a year like 1983 with 4 storms, and certainly if I told you there's 4 storms, I'd take my chances, but, you get some weird piece of junk that happens to just blow up and a major hurricane for 6 hours, but made landfall, so that's always the caveat, and we always say with all of our forecasts is, they're certainly not perfect, and, obviously it only takes that one hurricane near you to make it a busy season.
Okay, well, let's give Phil a nice round of applause.
I bet Dr. Gray's smiling, looking down on Phil. He's done a great job of carrying the torch beyond on that. He's got a press conference to do, so he's going to miss our next speaker. Jamie Rome is still in the silent mode. Cody Fritz is well equipped to carry the torch for Jamie and give us the update on the things at the National Hurricane Center. Cody is currently the lead of the Storm Surge Unit at NHC. And we'll probably kill his voice because after the break he's going to give his talk on Storm Surge. So, Cody?
Thank you. Appreciate the introduction. Well, in the spirit of Mr. Rome being muted, I can assure you that this presentation is anything but muted. So let's get into it. So this will be played by me, Cody Fritz. Again, I am the Storm Surge Unit Team Lead at the National Hurricane Center, but I will attempt to get through this presentation that Jamie has provided. So let's bring a little bit more laughter to the conversation, especially in light of that last talk, which really kind of freaked me out because I didn't see an ACE below 200 in any of those models. So how many of you think you can land an airplane? Okay, at least we have some takers. All right. Did you know that 1 in 3 Americans, including nearly half of men, were confident that they could land an airplane? Yeah? I know there's one person back there that definitely can land an airplane, but that's not fair to the rest of us. But what if I said there's a lot that goes on? There's a lot of controls. I've been in the pilot seat, and I can barely figure out how to pay attention to any one of these instruments and let alone land that aircraft as well. But there is a 0% chance that anyone can pull this off. And in fact, they did a study on this. Patrick Smith, commercial air pilot, had made a comment that nobody can land an airplane who's not an expert. And so the point of this is really that it takes expertise to effectively, guide us through these forecasts. But I wanted to play a clip in the spirit of landing an airplane. Can you go ahead and play that clip? Or can I just click?
Lift your nose, straighten your wings. Coming in too fast, watch your speed. He's coming right at us! Coming in too hot. Ease up on the throttle. Watch for that crosswind. Level it out. Aim for the numbers. Let the dip your left wing. Ease her down. Down. The brake. Pull the right handle.
So Jimmy and I joke a lot that that's usually me in storm surge during the landfall. So the point is, right, it's not easy to land an airplane, nor is it easy to forecast where a hurricane actually will go. And so the most effective way is to obviously rely on expertise, like at the Hurricane Center, or to also rely on the media to help us communicate the approach of a hurricane. But ideally, we need to focus on probability. So it's not enough to focus on one track. All of these different models providing us a solution to where a storm might go or how intense it might be, but at least look at the overall. Another clip in the spirit of probability.
I like you, Mary. I like you a lot. I want to ask you a question, straight out, flat out. I want you to give me the honest answer. What do you think the chances are of a guy like you and a girl like me ending up together?
Well, Lloyd, that's difficult to say, and we really don't...
Hit me with it. Just give it to me straight. I came a long way just to see you, Mary. Just, least you can do is level with me. What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance?
So there's a great thing to be learned there, is that our goal at the National Hurricane Center is to communicate the risk, not present a one-track forecast, but associate all the hazards that go along with where that storm might go and communicate that. So you guys all remember a couple years ago, Hurricane Ian impacted the west coast of Florida. We had a lot of great talks last year communicating the events of that storm. But the one thing that seemed to get somewhat lost in the communication of where that storm was going was the storm surge. And we constantly communicate how important it is to know the hazard of storm surge. It kills a lot of people, certainly within a single day. It is the most deadly hazard of all other hazards associated with that storm. But it seemed as if that hazard was not communicated effectively because so many people were concentrating on where the storm was tracking and looking at the cone. They thought it was going to Tampa, it was going north. But I can show you in the consistency of using probabilities to communicate the risk of storm surge, you can see how we were not only able to initiate or provide a storm surge watch at the very first advisory, but how consistent that watch and warning became outside of where that cone was. And never in the whole sequence was the watch and warning not communicated, nor the hazard of where the bullseye, being Fort Myers, lied directly within that hazard area the entire time. And why were we able to do that? It's because we were able to communicate the overall risk. Now, in the spirit of watches and warnings and the new theme here to really communicate the hazard associated with hurricanes, I give you the battle of watches and warnings versus the cone graphic.
I'm sorry about wrecking you today. I mean, but that's for the team.
No, that's cool, Ricky, that's cool. You know, I was thinking though, one time, it would be really awesome if, like, you could slingshot me in for a win.
Yeah, but, okay, but if you won, how am I gonna win?
Yeah.
Think about it.
No, I was thinking about it.
I mean, it's not like you're finishing 18th.
Nothing wrong with silver.
Nothing wrong with silver at all.
I'm just kidding you, man. I don't want to win. I'll just bury it down inside.
Bury it deep down in there and never bring it up again.
It's painful, and I love you.
So the idea here is not to focus so much on the cone. We keep reiterating this over and over, and maybe give watches and warnings a little bit more of a win going forward. So in light of that, we've done a lot of social science research over the past few years, and what's come out of that is the identifying ways to localize and personalize tropical cyclone information. And not only that, create products that are important, but some need to improve their depiction of risk and or uncertainty. So we have to not only focus uncertainty, but we have to communicate in a way that localizes that risk more effectively. So in light of that, this year, not at the start of hurricane season, but the National Hurricane Center will present an experimental cone graphic. That is likely to appear sometime in late August, just in time for the busy hurricane season that we just heard. So on the left, you have the old cone graphic, which highlights watches and warnings, basically a line along the coast, but on the right here, we have the new experimental graphic. We'll take those watches and warnings and show you the inland extent of those warnings as well. And that will provide a more effective communication tool of what the overall threat of that wind hazard actually is. And in hope, people will have a better understanding of what the actual risk to their area is. So this is a zoomed in depiction of what that might look like. Obviously you have a storm, generated or starting out in the Caribbean there, the Eastern Caribbean, and then moving northward. I think this was actually, was this Ian? I can't remember. Anyway, not my presentation, but you can see, obviously we'd be able to communicate those wind hazards, again, more effectively, and not just paint a line along the coast, which doesn't give you an overall depiction of what the true wind risk actually is. We're still working through some of the cosmetics, trying to identify the best way to, say, overlay. A lot of times you'll see a tropical storm warning in addition to a hurricane watch for the same area, and how we depict that overall area is still up for discussion, but this is one representation of what that might look like. Here's another example, obviously going from TS warning, hurricane watch to hurricane warning, with the hurricane warning being the primary hazard in that case, and would be ultimately the one on top of the other overlays. And you can see too how the cone has somewhat been lost in this graphic, right? We're focusing more on the hazards, making your eyes drawn more to the color of the wind hazard and not so much where that actual cone lies. And it hopes people can see, again, clearly where the overall threat is for their area. Again, just moving through here, and again, TS warning versus hurricane watch, you have the hatched area. Again, that's still up for discussion. We have some internal thoughts on that as well. But really, as the season goes on, we're going to want to hear people's thoughts about what this looked like, how it went. Obviously, we'll probably have to use it. So we want a lot of feedback as we go through the season. So by this time next year, we can actually communicate a little bit more. So that's Jamie's presentation. I probably went through it a lot faster than he would because he has a better ability to communicate these videos. But in any case, I will leave it open for questions since we have plenty of time for that. Do you guys have any questions